Hello, today we are going to start a new section. So the first part of this chapter is over. So next one we have to study about the movement and how the sound is traveling. These all things which we are going and the different properties of the sound, etc. We are going to study in this section. So firstly we have to study natural or free vibration. So before studying about the free vibration, you have to know about the term vibration. So vibration means which we all know in our from our day-to-day life. So suppose if you are taking the term vibration, uh, suppose we can take the example of our normal mobile phone. So mobile phone means when somebody called us, then the phone will starts to vibrate. Then how we can say that? Firstly, the mobile was in the state of rest, means it was not moving. That position we can say call it as the original position of the object. Here the object is mobile phone. So uh, the original position of the object which we are calling in physics as mean position. So when the phone rings, then the object will get some amount of energy and it will starts to move from its original position. Means it may be in up and down or in to and fro direction. So two types of vibration would be there, up and down or to and fro. So these kind of movements, the movement of the object from its mean position when it get sufficient amount of energy or disturbance, that is called as vibration. Then we have, so I hope you understood the term about the vibration. Then we have to study about the natural or free vibration. Then first thing which we have to study is that how this sound is related with the term vibration. So we know that sound is a form of energy. Sound is a form of wave. Sound is a form of energy plus it is a wave. The light, sound, etc. are waves only. It is traveling as a wave also. So we can take the movement of sound. The sound is moving like this only. So we can take the original position of the sound as sound is in here. Then from when we give the sufficient amount of energy, the object will starts to move firstly up, then it will comes to down, again will moves to up, then again will comes to down. So there is a up and down motion is there. So it is a vibration only. Understand? Then we can take so now we understood how the sound is related with the term vibration. Yeah, sound, we can say that sound is moving as wave by vibration, by the vibration. Clear? Then we have to explain, we have to study about the term natural or free vibration. For that, just take an example of simple pendulum. Simple pendulum we all knows. Simple pendulum means there is a thread which is hanging on a surface, and on the bottom part there is a bob or a ball is attached. So the when the bob when while we are not giving or providing any energy, the bob will be in its mean position. The this one will be in its mean position. But when we give a disturbance, when we give sufficient amount of energy, the bob will starts to move into and fro direction. Firstly the bob will moves to here, then it will comes to here, then again will moves to this side, then will it stop? No, again it will come back, then again it will move to there, will come back, this movement will continue. Then in here, the bow, firstly it starts from the mean position, then it will move to this direction, then it will comes to its mean position, then again will move to the left side, then again will come back to its mean position. That full movement is known as oscillation. That is known as oscillation. One complete movement, that is known as oscillation. Clear? Then if there is no resistive forces, means in our earth there are different types of resistive forces are there, means our air is a resistive force only. Then like that, different, each and every medium will possess a resistive force. But in case if there is no if there is no resistive force, suppose if you are taking space, or if you are in vacuum, once if the object starts to move in to and fro or in up and down, then there is no resistive force in space and vacuum, then the object will continues its motion. It won't stop. Such a kind of vibration, the vibration will continue until when we apply a resistive force. Such type of vibrations are known as natural or free vibration. So always remember that this is an ideal example, ideal case only. It won't take place in our real life. In our day-to-day life, it won't takes place. It is because in our day-to-day life or in our real life, there are plenty of resistive forces are present. I hope you understand. Okay, then next one which we have to study, damped vibration. I told you about, once again, I told you about the natural vibration. Natural vibration means the vibrations won't stop. Then in our day-to-day life, due to the presence of resistive forces, the vibrations of the object will stop, or its vibrations will decrease. Suppose if you are taking the case of simple pendulum, firstly the object travels up to this much distance. Then next case, when it comes after one complete oscillation, it won't travels up to this much. It may travels only this much. Next time it will travels only this much. After some time, the movement of the object will stop. Or in your textbook it is saying like this. So the vibration, due to the presence of resistive forces, the vibrations will stop. These kind of vibrations, the amplitude will decrease in here. Amplitude means the height of the wave. Okay, so the height means this one. Okay, this is the height. In natural vibration, the amplitude won't decrease. Amplitude means height of the wave. In natural vibration, amplitude will not decrease because there is no resistive force. But in the case of damped vibration, according with the time, due to the resistive forces, the amplitude of the wave will decrease, and after that it will comes to the state of rest. Clear? These type of vibrations are known as damped vibration. So in natural vibration there is no loss of energy because there is no resistive force. But in the case of damped vibration, there is a loss of energy because in our real life resistive forces are there. Clear? So you have to do two things. First thing, page number 115, the what it is called, the definitions of free vibration, natural time period and natural frequency. Okay, in natural time period I didn't do. Natural period means the time taking for the object for vibration, that is known as natural time period. And natural frequency means the number of vibrations in 1 second, number of vibrations in 1 second, that is known as the natural frequency. So, and in page number 116 there is a table which is explaining the difference in between free vibration and damped vibration. These uh, 4 things you have to write it on your copy. I am not giving it as a special different assignment. You have to write it on your copy. Page number 115 the definitions, and page number 116 the difference in between free vibrations and damped vibration. You have to write it on your copy. Okay, thank you.